All right, sounds good.
All right, I think we're ready to get started.
Yay.
So, welcome guys, welcome back to CS Club. And we're going to be talking about C++ today, which is another programming language like Python. Well, actually, it's different from Python, but we're going to be talking about it today. First, we're going to be going through some theory though, and that's what compiled languages are. Okay, so computing is pretty hard. Computers work by sending out electric currents to hundreds of millions of electrical components in a specific manner. But when we're program, we never actually have to worry about how power flows through which wire, right? Like we don't have to specify that we need to send power through logic gate number 1,035,000. And the reason why we don't have to worry about this stuff is because of abstraction. Abstraction is the process of removing insignificant details so that we can focus on more important tasks. In computers, details are hidden away by reusable pre-written code. So one example would be a web browser versus doing all this garbage, right? So a web browser is just a bundle of pre-written code that lets you browse the internet. And it lets you watch Minecraft videos without having to do all this nonsense. Example 2 is sending electricity through transistor number 132,947,234 versus finding the sum of 9 and 10. So the thing here is that to actually compute 9 plus 10, we might still need to send electricity through this transistor, but the system already handles that for us through abstraction, through pre-written code. So we can just type 9 plus 10, and then we find 9 plus 10 without doing all this garbage. Okay, example 3, which is the most important part, I guess most related to this lesson, is machine code. So machine code is just a sequence of instructions represented numerically. And these instructions are some of the most basic operations a computer can perform. And it's also the sort of language that a computer is able to understand. So for example, machine code would be able to add the values in registers 1 and 2 and put the result into register 6. And there's no such thing as a for loop, while loop, if else, or any of the other nice things we have in things like Python or C. So this is what machine code looks like. Well, this isn't what it looks like. This is what it looks like when it's formatted nicely. And it's still not very readable. Right. So the solution to this is compilation. And C++ is a compiled language. So this is foreshadowing. So compilation is an example of abstraction, in which it's the process of translating one programming language into another target language. And it lets us write human readable code, which is the important part, and translate it into machine readable code. And a big advantage of compilation is that we don't have to rewrite our code for different types of computers because the machine language, there isn't one unified machine code, right? Computers with different processors speak and understand different types of machine languages. So through compilation, we can have our little computer guy here translate into different machine codes or different machine languages. And the language that they invented on top of machine code was assembly code. So people got annoyed by trying to read giant blobs of numbers, so they invented assembly code. And assembly code is written in a human readable fashion and is compiled into machine code. But it was still pretty archaic compared to the languages we have today. There were no such thing as for loops, while loops, and there were still a bunch of things that we had to do manually. So eventually C, which was built on top of assembly and compiles into assembly, got invented. And then C++ got invented as a spin-off of C, and it also compiles into assembly.
So every language needs to be compiled because it needs to be taken from the human readable code to the machine readable code, as Trevor mentioned. But there are two, actually three, but we're not going to be talking too much about the third, ways for this to happen. And these are compiled and interpreted languages. So there are obviously a lot of different languages. Some of them are compiled, some of them are interpreted. Compiled means it takes the entire program, converts it into machine code, and then runs it. Interpreted means that it converts it into machine code line by line. And that's the basic difference between the two. Now, there are differences. Primarily, compiled languages are the fastest. Because they don't have to wait to compile each line before running it, they can just speed through it one after another. However, it also makes them harder to debug. It's easier to debug an interpreted language because, first of all, you don't have to wait for it to build after every test, and it's compiling it line by line, which makes it a bit easier to pinpoint problems. The problem, though, with interpreted languages is that in order to send your code, let's say you coded a game or whatever, in order to send that game to somebody, you have to send them your source code. Because if you were to compile it, you can only compile for one type of computer. I'm not sure yeah. So when you compile it, you remove the ability for whoever you're sending it to find your source code. But if you interpret it, you have to send them their source code, and then they interpret it when they're running it. And lastly, compiling does need compiling. Bit of a tautology there. But it's an extra time step. And for very large programs, compiling can take a while to convert the entire code file into machine code. C++, oh, I forgot about that one. Interpreting is nice. We'll get into what languages are interpreted versus compiled in a second. But interpreting is nice because it's cross-platform. As long as they have the interpreter on their machine, they can run it. Whereas with compiling, you need to have a different executable machine code for each type of computer. So some examples of compiled languages are C and C++, also Pascal and Swift, neither of which I know anything about, but Wikipedia said they were compiled. And then there are interpreted languages like Python, JavaScript, PHP, Java. And small side note that Python and Java are sort of a middle ground. They're compiled to bytecode, which still needs to be interpreted, but it's sort of a middle ground. I'm not going to talk about it too much, though. The point is, though, can you go back to previous? Yeah. The point is, though, that compiled languages like C and C++ primarily are significantly faster than Python and Java and JavaScript. And that's a lot of why we're going to be talking about it. Because for some coding competitions specifically, you actually have to run it in C or C++ because you need the extra speed. So I guess now we'll talk a little bit about how C++ works as a language.
Hi. Sorry. So this is the main function. In Python, there isn't really anything like it. But basically what happens is that code execution begins in the main function. So say if you compile your C++ program and then you run it, the first function that'd be called is the main function. And you can see that, oh, we didn't go through functions yet. So what this int here means that it means that the main function returns an integer as its return value. And this integer represents the status code. And when it returns 0, it means that execution was successful. But if it returns to anything that's not 0, it means execution failed, and that's not good. And you're able to call functions and declare variables in main. This is like, sort of think of it as your main program. Okay, semicolons. So this is something that doesn't exist in Python. I mean, it does, but people don't use it. So semicolons just mark the end of a line. And in C++ and most other languages with semicolons, you can actually have all of your code in one giant, really long line. But if you just separate everything with semicolons, then it still works. Pressing enter just makes it look nice.
Python does actually have semicolons. They're just not required.
Yep.
So if you want to have multiple function calls per line, you can put a semicolon between them, but you don't have to do it normally. In C++, every line has to end in a semicolon. Otherwise, it gets mad at you.
Yep. So in Python, this would be a monstrosity. I mean, it still is a monstrosity. But in C++, it actually compiles into machine code. And it's all fine. Okay. The next thing I'll talk about are curly braces, which is another thing that doesn't really exist in Python. And their most important function is that they're markers for the start and end of code blocks. And the code in if statements, loops, and functions are held between braces. So it's nice to think of them as containers for code. So this is an if statement. We'll go through examples of those in REPL later.
Another thing to mention real quick with curly braces, in Python, which I guess we're assuming a lot of you are used to already, the curly braces are pretty much replaced by tab indents. In C++, you don't have to tab indent. It's just sort of style convention.
Yep.
So, yeah.
Also, I think there's like 2 different ways to format curly braces, where you can put them right after like the if statement or the function, or you can make a new line. But since we're smart people, we put them right after the function and the if statement.
Agreed.
Okay, and the next most important thing that curly braces do is that they're markers for scope. So the definition of scope is the block of code where a variable exists. So, yep, like I said, in C++, scopes are defined by curly braces, and anything in between curly braces are their own scope. And okay, this is going to be a mouthful, but scopes nested in a higher scope are within the scope of the higher scope. And basically what that means in English is that, let's say we have this pair of curly braces here with the variable x declared. And then we have another scope in the if statement here. And what this is saying is that x exists in this curly brace block. But this variable y does not exist outside of here. So scopes with nested in a higher scope are within the scope of the higher scope. I probably could have worded that better, but yeah.
So variables, arguably one of the most important parts of programming, need to be declared and defined slightly differently in C++ than in some other languages, not all languages. But there are 2 parts to creating a variable. There's the declaration, which sets aside a space in the memory for whatever the variable contains, and it gives it a name and type. So in this case on the left, we're declaring a variable named x with type int. And it's important to give it the type so that C++ knows how much space in memory to give it. In the case of int, I think it's 8 bytes or something like that. And then, but at this point, x doesn't hold anything in it. The space in memory that x has doesn't have anything of value in it. So we need to define the value of x, which can be done pretty normally. X is equal to 4. Sets the value inside of X to 4. You can do it on two separate lines, or you can do it in the same line. There are cases where all three of these examples here will be used, but you can define and declare in the same line, which is nice to keep your code tidy. So there are lots of different types of variables. Here are a bunch of different types here. There's bool, which is just a Boolean value, true or false. Char, is a character. Note that it's a single quote, which in C++ denotes a character rather than a string. There's an int, as we talked about before. The number there is actually the largest integer that you can get in C++. So if you want it to be longer, well, you can use a long, which is a bit of a funny name. Long it's more of a modifier to a type, to be honest, because you can do long int, which is kind of a bad example because it's the same thing, but it makes the type longer. In this case, it stores a significantly bigger number. There's float, which is for floating point numbers, decimal numbers. Double has twice the precision of float. So if you want a big decimal number, you can use double. Then there are pointers, which is the first one there, G. That's a little bit funny of a definition and declaration there. If you remember back to 2 lessons ago, I believe we talked about this. So it's an int pointer is the type, which means it points to an integer. Its name is G, and its value is the address of the variable C. So in other words, it's a pointer to whatever is stored inside of the variable C. And then I also included below how to pull out the value of it. So if you wanted to pull out the value of this pointer, you would do star G, which gets whatever the pointer is pointing to. This is one of the more confusing parts of C++, pointers and references. And then there's strings, which is interestingly not included in by default in C++. It's part of the standard library. So you have to do standard std : string, and then you can store a string inside of I. Oh, good question, Callum. A char pointer, if I'm not mistaken, is the default way to do string in C++ because it points to, I believe, a sequence of characters. Although I'm not sure. Trevor, maybe you can chip in here, but I would have used a char array.
Yeah. In C, strings are defined as arrays of chars, but in C++, this is deprecated, so it's preferred to use std string.
Okay, cool. And then I also have return 0 at the end. Oh, that's animated? That. Whoops, I didn't know that either.
Okay, yep.
Could I ask a question?
Yeah, sure.
So I remember once so let's say if you had an integer and you would have something like 1 + 1, you would obviously get 2. But I remember once I was playing around with like floats or something like that, and like if you do an operation or something like 1 + 1 or something, instead of getting 2, something I would get like I'll sometimes get like 1.9999998.
Yeah, so that's floating point imprecision. So in all programming languages, it's very difficult for the computer to store an exact decimal number. So instead, they approximate it to a power of 2. And that's where the slight imprecision comes from, because not all decimal numbers are powers of 2.
Yeah, I was like.
Oh yeah, I there's a little bit of an error in my code here. I think I should have had 5.6f and 14 point whatever the.
I think it's fine.
To specify that I think it did it automatically for me, but
Yep.
in some
C++
situations.
types are complicated. Yeah, about the 1.999 thing. A nice way to think about it, I think that I found online was that since computers store numbers in base 2, there are some base 10 numbers that can't be represented in bits.
Oh, I
So
see.
something like, like how 1/3 is 0.33333 in base 10.
Yeah.
Like around the same thing's going on with binary here.
Oh, that makes sense. I see.
Right. And the last thing I want to mention is that the reason why stars, the star operator is used twice and for different purposes is because it's overloaded. Well, I think. Well, it's not really an operator here, but there's pretty much two different meanings for the star operator. And here
Mhm.
it means that it's defining a pointer, and here it's called a dereference operator, which is it takes a reference or a pointer and gets the value out of it. All right, let's go to some examples.
Yeah, examples.
I have REPL on here. Hold up. Let's see. I think I have to switch windows. Kegan, did you want to use your IDE or did you want to use REPL?
I think you're doing the operators, right?
Yep.
So for now, we can just switch to my stream when it comes time.
All right, sounds good. I'll be starting another stream. Here you go. All right. So a piece of code that you guys might have seen in our pictures in the slideshow was this hashtag include and this thing. And what the hashtag means is that this is a preprocessor directive. And what the preprocessor is that it's just stuff that the compiler does before actually compiling the program. And hashtag include essentially just copy and paste whatever is in this file into this program. And bits/stdc++.h is just a header file, which is what the .h is, that gives us access to all of C++'s functionality. So for now, if you want to use everything that C++ has to offer, just include this at the top. Okay, let's get started. First things first is that we have to make our main function. Oops. And this returns 0. I'll be going through all of the operators that C++ has to offer. So first up is the star and the and the ampersand, which is what we saw in the presentation. And like I mentioned, the star is a dereference operator. So if you had a pointer A is equal, let's just make an int up here, to 1, and pointer A is equal to ampersand x. So the ampersand is called the reference operator, and it gets the reference to the memory location. Or it just gives you the memory address of whatever variables after the ampersand. And you need to do this when you're assigning in a pointer. And then the dereference operator is just this. And it gives you the value that's in the address that A points to. Okay. Next up is the arithmetic operators, which is the same as the ones in other programming languages. So we have the star for multiplication, slash, the percent sign for modulo, the plus sign and the minus sign. And in Python, one thing with the slash operator or the division operator is that usually we'd have to worry about float division versus integer division. In C++, since types are, I think it's called strongly defined, integer division only happens if you're dividing two ints. So, okay, this will be a comment. Is equal to integer division. And float division happens when at least one of the operands are floats or doubles. So example now is We'll explain what this thing means soon. All right, so let's say we had 1 divided by 5. And I guess we should make variables for those. B is equal to 1. C is equal to 5. So you're actually able to do this too. If you have two variables that you want to make ints or any data type, just separate them with a comma, and then you can do this. So we have an integer b and an integer c. Let's see what b divided by c is. No, okay, I hope I'm right. No, I forgot a semicolon. Yep. Let's see. Okay, that's a warning. We don't care about warnings. Okay, so we see that the output of the program is 0. And what happened here is that integer division happened, which is 1 divided by 5, we get a decimal value. But since this is an integer, we just use the floor. So we just get the floor, which is 0. And if one of them was a float, so let's say if 5 was a float, then we should get a decimal value. Because if one of these is a float, then, oh, I forgot a semicolon again. Guys, what's happening with me?
Imagine forgetting your semicolon.
I'm ashamed of myself. But yeah, we see we get 0.2. And the reason why we get a float as an output now is because one of the operands is a float. Okay. Oh, we'll get rid of this. Next thing I'll talk about are the conditional operators, which is the same as in Python. So you have the equals, less than, greater than, less than and equal to, greater than or equal to, and also the not equal to. So it's mostly the same. Actually, it is the same. And then we have the assignment operators, which is also the same as Python, except for 2, which is, we get all of these ones, mod equals, modulo equals. Then we have plus plus and minus minus. And what these guys do is that they just increment a variable by 1. So let's use x. See, x was already declared here, so we can just redefine it here. X d end out. This is pretty much C++ version of print statements, and we'll go more in depth later. Okay. So this operator increments x by 1, but let's see what the output of the program is. And also let's get rid of the warning that comes from this. One and 2. So there's actually 2 ways that we can use the plus plus and minus minus operators, which is we can go like this, or we can put it after, or we can put it before. So the reason why it printed 1 instead of 2 here is because x with the plus plus after first returns the value of just x at the current moment, and then increments it after. So this evaluates to 1, and then x gets incremented later. And then with plus plus x gets incremented first, and then the value of x gets returned to here. So if we look at this, you get 2. And the same thing happens with minus minus. And this operator is also why C++ is called C++, because it's C plus equals 1. All right. And the last type of operators I'll be talking about are the Boolean logic operators, or the logical operators. I guess they're just Boolean operators. And they're also the same as with Python, which you can use not and or. But there's also another way you can type them, which is more traditional and cooler, which is the double bars. Wait, hold on. Exclamation mark for not, double ampersand for and double bars for or. So let's see these in action. Let's see. True. Let's print not true. REPL takes a long time. Yep, it's gonna be way faster when Kegan's presenting. Okay, let's get rid of these. Okay, so print 0, which is the right answer. The thing in C++ is that booleans are also numbers, but they're actually just numbers that have a width of 1, that are stored in 1 bit. So they can be 0 or 1, where 0 means false and 1 means true. Okay, let's try true or false. No, oh, okay. This has to be in parentheses. Operator precedence is what's happening here, I'm pretty sure. And that's really, really complicated. Well, actually, it's not really complicated. It's like bedmass or PEMDAS for operators. But there's a lot of things that we need to remember for in terms of the order of operations, just because there are so many operators in C++. So at the end of the lesson, I'll send a link that details the operator precedence in C++. And then you can just use parentheses to just like how you'd use brackets in bedmass. Okay, let me try this again. And that's true. True or false? True. And those are pretty much all the operators, well, all the important operators that C++ has to offer. So I'll be handing this off to Kegan, who'll be presenting some if statements, for loops, while loops, and other stuff.
Could I ask a random question again?
Yeah, sure.
So I'm seeing that the main function is an int. Do you have void functions in C++ at all?
Yep. Void functions do exist. It's just
Okay.
that, yeah, it's just that the main function, they like made it so that it has to return a status code.
Okay.
You don't actually have to return anything from the main function. It can be void, and that's perfectly valid. It's just generally preferred to use int main because I don't believe you can force exit from a void main. And as Trevor said, it is better to return error codes and stuff like that.
Okay, that makes sense.
Okay. Wait. Was I supposed to go through the if and for?
I was gonna be doing that.
Okay. Well, off to you, Kegan.
Okay. Everybody can see this, right?
It's still loading, so for me at least.
Nope, it's loading for me too.
Why is it being like this? That's strange. Is talk a little bit more about input and output, which Trevor used in some of his examples. Okay, IOStream is needed. You need to include IOStream if you want to use functions that I am going to be showing you right now. So in order to take in some input, let's say I wanted to take in an integer. So I'll say, I'll define x here, and I'll say, so what this does here is I'm using the function, let me zoom in a little bit. I'm using the function stdcn. So I don't know if we've talked about this already, but the double colon means that this is part of the standard library. So I'm using the standard input stream and putting that into the variable x. So, whoops, if I run this, it prompts me to give an input, like, and then nothing happens, which is what you would expect because it's not actually outputting anything. In order to make it output something, I can do being added.
踢完了。
Oh, my bad. I need to take a second to put up attendance. Only I can do that.
If you
One
want,
moment,
I could
please.
handle the rest because the ball's offline.
I'm putting it online right now. It takes like just a second.
All right. Oh, just a side note. So the bits/scd c++ .h thing that I mentioned before includes outstream too. So it includes all of the C++ things.
Wait a minute. Sorry about this. All right, there we go. Attendance is up. I imagine so. Yeah. So an interesting thing about this, what happens if you don't enter an int? If I don't enter an int, I can enter in whatever, and then it just sets to 0. Yeah, good point, Andrew. This only works for cout. This only works for cin. I like to remember it because it's going from the input to the variable. It's coming from the variable to the output. Okay. A nice thing about this is that you can string them together. So I can say also so something like this will print out x and then is the value of x and then new line character. And 1 second. Okay. And now if I run this, I can put in, I don't know, 57, and 57 is the value of x. So that's basic input output. I will also real quick talk about if statements. So if statements are useful, as you may know. Let's say I wanted to say something if the value is greater than 10. So I can say x is greater than 10, then making sure not to forget my my semicolons. Okay, so if I run this, I'm going to put in 4. Nothing happens. I should probably go a little bit faster. I'm taking up all Trevor's time. 15. That's a big number. And then there's also else if x is greater than 0. Notice that it's else if rather than elif for all you Python people. Oh, that's a. Trevor, would you rather I go over what you wanted to talk about?
Hey, yeah, if possible. I think
Okay.
I'll have to stay in this call though, since I'm recording.
I
So
don't
I'll just
remember
tell
how to
them
do
that-
classes. I didn't review that because I thought you were going to be doing it.
Oh, it's
So
fine. I'll
we'll
just stick
stop
around.
it.
I'll
We'll
tell
just
them I'll
stop
be
at
late.
functions. Okay, fair enough. Okay. Else if x is greater than 0. And then stuff like this. And the last part is else. It's fairly similar to other languages. And then the last thing I'm going to be talking about is the for loop. So there are actually two different types of for loop. In let me just switch this for example purposes to string real quick. So there are actually two different types of for loops in C++. The first kind of for loop is yes, Luke, it should DM you. Here, let me. Okay. The first kind of for loop is it's the kind of for loop I believe is used primarily in Java and lots of other languages, where you have a variable for int I. So we're defining a variable, or declaring a variable, and then we're checking a statement. So for example, I is less than x dot length, and then we're going to be modifying it. So I plus plus, for example. And you don't. It's interesting. You don't actually have to have. So Callum, you don't have to have any of these three. Well, I think you have to have at least one. I'm not sure what happens if you have none. But I could just, if I left this out, well, it would throw an error because it doesn't know what I is. But if I, for example, say int I back here, this will still run as long as you have the semicolon. But I'm just going to be putting it inside. Fair enough. Okay. And then so this, if I haven't made any fatal errors, should run. So I'm going to type in something like hello, and it prints it out line by line. The other, better in this situation, way of doing it is actually more similar to what it does in Python. I can say for char I in x. And this is, I'm not sure what to call the colon here, but it'll go through each character of I, each character I of x. Empty string. Did anybody get a DM from the bot? Because it might just not be working. Okay, that's good. I will say something like, right. Something like this, and this will do the same thing. Nice. So those are the two. Man, I don't know what's going wrong with the bot. That's strange. String x.
Someone is at the front door.
Andrew. Wait. String x. Well, you do have to include std string if you want to run it as a string. Okay. And Trevor, do you want to jump in here, or you want me to do while loops and functions?
Yeah, sure. I can I could hop back onto REPL if you want.
Okay.
All right.
Here, let me.
All right. Welcome back to REPL. So the last thing we'll be talking about are while loops. There you go. We need to keep the main there. Turn 0. So while loops in C++ are really similar to while loops in Python. The only difference is that you'd add parentheses around the conditional. So let's have a counter. $109. Okay, so while the value of counter is less than 109, we're going to perform this code. So let's just print counter. There we go. I forgot to increment counter. Oh, plus plus. Okay. Counter plus plus. So we do everything all in one line. Here we go. It prints all the numbers from 0 to 108. Okay. So the last thing I think we'll be going through today is classes. And it's already been 50 minutes, and I guess if you guys, we're not really going to be explaining how classes in object-oriented programming works. So feel free to tap out if you don't want to listen about classes. But if you do want to learn how classes are done in C++, then stick around. So you just type class, and then the class name. Let's make a class called person. And then notice that we don't put the class in the main function. We put it outside. Okay, then a constructor. Oh, yep, access modifiers. So what you do in C++ to define which variables and which functions are public and private, and I guess protected, you would have these things with colons, which is really weird since usually C++ uses braces. But with these, to define, let's say, a public field or a public member variable, you just indent it here under the public, and let's say, actually, let's make a string. Name and int h. So these are all public. Here is private. Social security number. How about that? And protected, we don't care about protected. I'm pretty sure they're just the variables that you would inherit from a superclass. But we won't talk about that. So only worry about public and private. Basically, public, you can access these variables from outside the class, and private variables you can only access inside the class. And what that means is classes have functionality. So you can have class methods. So something like say hi. And here, cout hi. I'm pretty sure able to do this. Okay. Yep. The plus sign is also a concatenation for two strings. Okay. So when we have an object of the class person and we call person.sayHi, then, oh, it should be this name. This just refers to this instance of the object. Yep. If you guys want to learn more about object-oriented programming, feel free to just stick around after class. But yep. Here's a
Also, I would
constructor.
like to direct your attention to c++.com and every other website online, like Stack Exchange and that kind of stuff. There's no shame in checking documentation and forums constantly. I mean, even in the CCC, they don't expect you to memorize everything. You can still use c++.com.
That's exactly how you learn.
What was that?
Yep. Sorry, did someone say something?
Oh, I just said that when you check forums, that's exactly how you learn.
Mm-hmm. Like I'm sure both Trevor and I checked documentation several times, even during this presentation.
Yes. Okay. Actually, okay, documentation, learning how to read, just being able to read documentation is a very, very nice skill, because like if you try to figure out everything by yourself, then it's not a fun time. Okay, but what I coded here was a constructor, which is it constructs an instance of the class person. And this is the bad method, or I guess, well, it's not really the bad method, it still does what it's supposed to do. But the more conventional method would be something like this. Age, then you have a colon after, and something like name, age. And I forgot what these were called, but I think they're called initializer lists. And the reason why these are so important is because if you have a constant field, something like x, well, since you can't change the value of a const, then, well, you can't really assign it in the body of a constructor. So you'd have to do it somewhere here. And this is valid. So setting x to 1, setting this.age to age, and setting this.name to name. So this is constructor initialization in C++. And the thing is, the main reason why we're going through C++ is because of the CCC, which I don't think we'll be able to write because our school isn't doing competitions. But
And it's also not being allowed to run online, which is unfortunate.
Yep. Yeah, so in competitive programming and actual programming, well, competitive programming and like project or work programming, it's really different. Usually you wouldn't use classes in competitive programming, which is why we're not really going through this thing in detail. And it's also why we talked about bits/std c++.h. It's because, right, it's just you're solving one problem. No one really cares about how neat the program is. Right. And last thing I want to mention before we get past 1 hour is that I hope you guys noticed that we haven't really talked about container data types like arrays or lists. And that's foreshadowing to next week. All right. I think that's all we have for this lesson. It's a really long lesson.
So a question: if I were to go on CCC and look for past contests, then would you recommend, like, am I supposed to practice on C++?
It's really up to you. C++. I know that some of the really, really hard problems, sometimes you'd have to use C++, but if you're more comfortable with Python, it's fine. I use Python, and it worked out.